Hello, this is just a short video here for anybody who's thinking of doing any sort of job or restoration on an old radio they may have in the attic or they've purchased. Just a quick one. Just purchased this one. This is a General Electric L542. I'd never seen one before and I bought it from eBay. I would say I paid a bit more than what I would have wanted to pay for it, but the guy did say it was a rare, and looking around on the internet and elsewhere, I've never seen this radio before, so I'm going to take that as, yes, it is a rarer model. Can't say how rare it is exactly, but it's pretty unique in the way that it's got a higher killer cycle frequency range, which obviously would have been the police sort of radio area back in the day. I think it's a 1939, 1940s era American radio, which would be commonly known as the All-American 5, hence the 5 tubes. What I was more concentrated on is electrically making these safe. Now, you can't change the design quite drastically without causing an upset of the chassis and how it works. However, there are certain precautions you can take, mainly common sense. However, not everybody has common sense. So, speaking from an electrician's point of view, such as myself, these are dangerous. If it's sat on the side of a cupboard operating day in, day out, it's safe. If you touch anything metal on this, however, it's a semi-live chassis, you're going to get a belt. Now these run on 110 volts mains. In the UK we have 230, which obviously isn't really for it, but we can have step down transformers. However, 110 volts still hurts and it's still lethal. So things to look out for is chassis will be live, so assume that anything metal while the unit's operating could be live and you're liable to get an electric shock off these. This is why you have insulated Bakelite, plastic, wooden knobs, so don't even think about touching anything metal while it's on. Also, if you have a look around the back, the chassis itself, all metal, will carry a current too. And another thing to notice on this radio is, you see the metal tabs on the chassis there? Look at this horrible botch. I'm going to repair this. That tab there is directly welded, spot welded or riveted onto the chassis, which means that tab there is a mounting tab to the wooden cabinet. Now underneath you'll have 3 holes, as you can see. That's where screws through the base to the chassis would be. Now underneath, you're not going to be touching it underneath while it's on, hopefully not, but they will be live too, so there is a chance of a shock there. Now you can polarize it so that the neutral is on the chassis and the live is going to the actual tubes themselves. However, there's still a potential of a shock there as well. One more thing to notice as well is asbestos risk. Now we all know how deadly asbestos is. Now here's a big lookout. See this old cord here? I'm going to dispose of this carefully because back then in the American radios, all the tubes in series, the filaments should add up to about 110 volts mains. It never always did. So what they used to do is they used to have a special type of cord, which was called a resistance cord, and it's just basically a resistor wound cord. Inside you've got the remnants of what would have been an earth. This here would have been the live, the black. This piece here, which I've taped off, it looks white. That's a fiberglass sleeve. Inside there is a very fine piece of wire, very, very fine, bare. Inside an asbestos chrysolite, white asbestos cover. Whole idea of it is it's acting as a mains dropper, so depending on the length of this, depending on the resistance of the wire, let's say for argument's sake, for every metre there is about 100 ohms, should we call it, of resistance. 110 volts through 100 ohms, you might lose 2 volts. So what they'd work out is the maximum maximum voltage these tubes can take. Let's say for argument's sake it's 90 volts, but your mains is 110 volts. They want to drop it, so they use X amount of meters times how much resistance you'd need. So you sometimes get a radio with an unusually long power cord. Now it's a fatal mistake to just cut this off and put a meter of standard flex on it. So you're going to have to do a little bit of calculation, Ohm's law, and work out how many ohms of resistance this wire actually has. Now this could have been longer, it could have been shorter, but it's something I'm going to have to worry about. But the main thing is it is containing white asbestos. That's why I take the end up. The other end inside the chassis, I'm going to disconnect, measure the resistance and see what I've got, and then dispose of it properly. Put it in a sealed up bag, mark it up as asbestos, and take it to a council site or an authorities which can deal with it. Other than that, I'm looking forward to doing this. I'm going to have to repair the scale guide cable that was broke. Someone's put some god awful newer wire on the antenna. A bit of a capacitor hanging on there that also ties into the antenna. God awful filter can capacitor which they've just taped on the back there, which is horrible. So far the speaker magnet's looking a bit strange, but everything else looks untouched. I've not tested the tubes yet. The speaker looks okay. I might just give that a 1 volt and see what happens. But yeah, speaker transform looks all right. But yeah, it's a nice unusual set. I might just leave the wood finish as it is because it's got a nice bit of decal down there that I don't want to destroy. So I hope you've took some information and knowledge from this video. If it helps you, great. I just want people to stay safe while they're enjoying the hobbies. Okay, thank you for watching. I'll give you an update.